In the coming 3 decades, global GDP will more than double. That roughly means that we will be producing twice as many TVs, mobile phones, air conditioners, fridges, etc. Until 2050, the urban population will grow by 50%, or over 2.5 billion people will be added to the number of people that already are on this planet. And this means that we will be building 50% more city space, including urban infrastructure, buildings, roads, railways, drinking water supply, sewer water treatment plants, power infrastructure, etc. In that same period, we will be radically changing one of the most fundamental building blocks of society, our energy system. The deep decarbonization that is required to avoid catastrophic climate change will require a rapid scale-up of production of solar cells, wind turbines, electric vehicles, supergrids, smart grids, electrolyzers, hydrogen pipeline, and so forth. For the energy transition, we are now in the phase of rapid exponential expansion of crucial technologies, or, as the economist Richard Baldwin puts it, the holy cow moment. And this refers to the fact that the human mind tends to overestimate the impacts of novel technologies in the early stages of development and underestimate it in the phase in which the mature technology is taking over the market. Currently, we are in the middle of the holy cow moment. For electric vehicles, you can see that all major car manufacturers are tumbling over each other to announce ever earlier dates at which they will go full electric vehicles. The materials required for the energy transition consist of basic construction materials like steel and concrete, but specific technologies will also require specific materials like rare earths for wind turbines and electric vehicles, and copper and aluminum for the transmission grid, and nickel and lithium and graphite for the batteries that we use in the EVs. Another general trend is that products are becoming more and more complex in terms of material composition. Electronics nowadays can contain over 60 elements, and the concentration of gold in a mobile phone is an order of magnitude higher than in the ores from which it is extracted. Next to that, in most places, the recycling of these elements from electronics is still quite limited. Next to the energy transition, the rapid introduction of new IT technologies like the Internet of Things, artificial intelligence, 5G networks, photonics, edge and quantum computing will be embedded more and will embed more faster and more complex electronics in every part of our life. The infrastructure and products required to make use of these new technologies will require significant amounts of these critical raw materials. The common denominator of all these future developments is that we will require a lot more materials in the 30 years ahead, including critical ones. This rapidly increasing demand raises all sorts of questions like, what are the environmental impacts of mining and refining of all these materials? Can we source these materials in a responsible way? Will we run into issues of scarcity or depletion of resources? And how will this affect the geopolitical landscape of supply and demand and security of supply? How can we use circular strategies in urban mining to mitigate some of these impacts? Can high-tech mining or deep ocean mining prove to be sustainable alternatives? All these questions will need to be addressed in the coming decades.